we mentioned more than one time that we get this line, which is the statistical forecast that BPC is giving me. Basically, what it says is that if everything remains the same for this product based on historical values and trend seasonality and base assumptions, um, this is the expected sales. So this is built and this is delivered by BPC using a statistical model, and we can access that on this form, statistical forecast. So if I go into here, and this is basically just for information purposes for the store manager, right? He can see that for a specific product, the first one, the shirt Savana Air Sabug, the first one, um, basically the model is very robust. So I have a very robust model. Why? Because if you notice there is here two lines. One is a blue line that represents the actuals. So we have actuals from 2014 January until 2016 month 8, and this is the profile of the line, and we have a line just above it, basically, that it's able to fit the blue line. It's an orange line that basically uh, makes a regression against the actuals and can actually predict the past, right? And based on the accuracy of the past, predict the future. So going forward, this is the prediction, and this is the line that actually I'm seeing in here, right? This line 18, 17, 18, 19, 20 is basically this one, right? Um, is this one. Okay. And how is this done? Basically, BPC leverages a common tool that everyone has on Excel called the Solver. And basically, we do two things. We pick up what BPC is very good, which is the management and modeling of data, right? We have data in the database, we pick it up, we model it, we send it back in a secure way, and we get an advantage called something that Excel has called the solver, which is this stuff here. It's this the solver. The solver basically does a regression analysis and do a maximization or minimization of 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 an objective function. And the model is like this. I give to the model basically the actuals. And again, this is not on the Excel. This is coming from the database on BPC, right? Quantity sold. Then I make an assumption about what is my perspective, what is the equation that better represents the selling profile of this specific product. And here I'm assuming that the selling of a product uh, has this kind of equation. It has a base value. So normally I sell this amount. It has a trend. So normally the trend should be positive or negative. So I'm selling more of this product or less of this product. So and then I have seasonality. So in specific months, I sell more or less of the year. So if in January I sell more than in February, so there is a seasonality. So I build this equation, and after I build this equation, I'm explaining how the model is actually built. I build this equation, I get the actuals, and I get like in our example, I'm getting 24 sample values. So from 2014 January until 2015 12. So I have 24, and I will build my model based on 24 sample values. So I get the actuals. Then I create an equation that, in my perspective, should represent how the product is sold. Then I create a new column called the error. Basically, what is the error? Is the subtraction of the actual minus the equation. So the error, right? The error. And then I have the same thing, which is the error but squared, because I need to square the error so that um, the negative effects um, are not opposed to the positive effects. So, okay, I need to square it. And then basically I ask the solver to identify me the base, the trend, and the seasonality. The solver will identify this. And I will run the solver to identify what are the base, the trend, and the seasonality by doing the minimization of the sum of squares. Basically, this is a regression model. So, and the solver, if we see here, has identified these values. Base, this is the base, this is the trend, so it's upwards, and these are the seasonality, right? And the seasonality should sum zero, the sum should be zero. So you see the line, the orange line. If I delete basically the model, right, the line will be flat. So basically, this is the intelligence of the thing. But again, this is not on Excel, this is saved on the database. If I refresh it, it will come up again. Let's see how this actually works in practice. So if for example, if I'm nothing in here, I just have actuals, and so my equation is zero, so I cannot explain nothing, right? Because the trend is zero, the baseline is zero, the seasonality is zero. My error is 100%, and my squared error is basically very big, so I cannot explain anything. So if I run the solver, if I go to data, I run the solver, and I'm saying on the solver, and sorry for this, it's not on English. If I run the solver, basically I'm going to say, what is my target? I want to minimize, this is minimize. I want to minimize the sum of squares. And this is summing the squares, the 25, by changing the base, the trend, and the seasonality. This is something that solver will identify. And my constraint is that I want that the sum of the seasonality is equal to zero. So let's run the solver, and it immediately tries to identify. It will do an iteration. It will be 10 iterations, and it will try to identify what's the base, what's the trend, and what's the seasonality. This will take up around 5 minutes because you will do 10 iterations to identify the best fit. So in a couple of seconds, we will start to see the line, the orange line, move up and down and trying to adjust to the blue line. Let's try to see that happening. And okay, it started. So it started to trying to identify a base value, and a trend. So no up or down, just first a tentative to identify a base and a trend. And now it's starting to identify seasonality. So we will start to see this becoming a curve and not a straight line, just in a couple of seconds. And by the way, the solver is an add-on to Excel that everyone has. I would normally say that we could have very good statistical forecasting solutions, but I think we need to know how to walk before we run. And this is really trying to not putting statistic as a black box, but basically showing how everything is calculated, which is I think is nice. Because after people understand how actually the statistic works, we can more easily go through more advanced statistical software solutions. If at least this is my perspective. So as you see, it starts to try to figure out what's the best values, and he's trying to adjust the base, the trend, and the seasonality. Okay, and you can see down here that we are in iteration 3. We will go until the 10. So and you will try to produce the best coefficient possible, and the best reduction, the sum of squares, the minimize the sum of squares. So we are almost there, as you're seeing, right? and we are at iteration 3. So we'll have a lot of them. I'm going to pause the video for a second. So the solver is finished. It took a little bit more than 6 minutes, something like that. Now I can accept the solution, and that's it. What I need to do then is basically to save the data. And while I'm saving the data, the I will be saving the forecast made and actually the model that you see in here, right? So I've saved all these values here, and I also saved um, the forecast. So if I go here, you can easily see that I'm able to produce a forecast going forward. So this is an easy way to actually have statistical dynamics in Excel and BPC, taking advantage of the two solutions, and using Solver, which is a very robust add-on in Excel, and it's free, by the way.